In this lecture, we will discuss the concept of frequency reuse. The concept of frequency reuse is based on assigning to each cell a group of radio channels used within a small geographic area. So that is, cells are assigned a group of channels that is completely different from neighboring cells. The coverage area of cells is called the footprint and is limited by a boundary so that the same group channels can be used in cells that are far enough apart. So in the previous lecture, we have seen that the area, the coverage area up to which the signal strength will be greater than certain threshold is called as the footprint of the cell or definition of the cell. Frequency reuse or frequency planning is a technique of reusing frequencies and channels within a communication system to improve the capacity and also the spectral efficiency without employing high power transmitters. This is we have already discussed. In the case of conventional mobile telephone systems, they used to have the high power transmitters and they used to cover large geographical area, but that is a disadvantage. So in the concept of cellular, we are using the frequency reuse concept in which we can assign to each cell a group of radio channels within a small geographic area with small antennas, and then we can repeat the same frequencies. We can reuse the same frequencies by maintaining certain distance. There is a formula you will see in the next slides. So a radio channel consists of a pair of frequencies, one for each direction of transmission, that is used for full duplex operation. A particular radio channel. So here don't be confused. We are using the term channel for frequency. So a particular radio channel, say F1, used in one geographic zone as named it as a cell, say C1, with a coverage radius R, can be used in another cell the same coverage radius by maintaining a distance of capital D. So the frequency reuse is the core concept of the cellular mobile radio system. Because of this frequency reuse concept only, nowadays, now we are enjoying the technology and they are able to provide to more number of subscribers with the limited number of channels. So the channels, the available channels, the allocated channels are always fixed. So we cannot increase the channels, but the way, the efficient method, how we are utilizing the channel comes into the concept of cellular. So in this, one of the concept is frequency reuse. Because of frequency reuse, that is, we are able to reuse the same frequencies number of times by maintaining certain distance D and some rules and to avoid the interference. So we are able to provide to more number of subscribers with the same number of available limited or finite channels. So in this frequency reuse system, users in different geographic locations, that is different cells, we can call the cell as a geographic location also. So may simultaneously use the same frequency channel. So the frequency reuse system can drastically increase the spectrum efficiency, but the system is not properly designed, then there will be the occurrence of interference. So interference due to the common use of the same channel, that is same frequency if you are using, is called as co-channel interference. Co-channels are nothing but the adjacent channels which are using the same frequency. That is interference caused due to the common use of the same channel is called co-channel interference, and it is a major concern in the concept of frequency reuse. As we are using the same frequency, there is a chance of co-channel interference. So while designing a cellular system, we have to take into account the concept of co-channel interference. So that's why we are maintaining a certain distance. You can see here in the figure, we are maintaining certain distance of capital D between the two cell coverage. C1 is the one of the geographic locations, and this is the another geographic locations where we are using the same frequency F1. So you can see same frequency F1 is used in these two geographical regions by maintaining certain distance D, and the radius of the coverage, cell coverage, is capital R, and so carrier to interference ratio is equal to gamma, and Q, the co-channel interference reduction factor, is equal to D by R. So all this we will discuss in the next slides. So frequency reuse distance is nothing but the minimum distance that allows the same frequency to be reused will depend on many factors such as the number of co-channel cells in the vicinity of the center cell, the type of geographical terrain contour, the antenna height, and the transmitted power at each cell side. So all these we have to take into account for maintaining the minimum distance between the same frequency to be reused. So here you can see the distance for a k number of k is equal to 4. K is equal to 4 means the number of frequencies. If the number of frequencies are 4, these 4 frequencies are repeated. We are calling these 4 frequencies as a cluster. K is equal to 7. You can see here the example they were showing here. A cluster. Cluster is nothing but we are using the group of frequencies 7. That is K is equal to 7. So F1, F2, F3, F4, F5, F6, F7. With this group we are calling as a cluster. This group is repeated number of times. You can see again here it is repeated. And you can see here the red color F1. It is same frequency. The same frequency F1 is again used in this another cluster by maintaining a distance of capital D. So what is this distance D is here we have given. If the number of the cluster is equal to the cluster size is 4, that is K is equal to 4, and so we are using 4 frequencies. For example, F1, F2, F3, F4. Then the distance that we are maintaining between the two frequencies is 3.46 R. So when the cluster size is 7, the distance is 4.6 into R. Here R is the radius of the cell. Here the R is the radius of the cell. So if the cluster size is 12, the distance we have to maintain is between the two frequencies is 6 R. This reuse distance. We will call this distance as reuse distance because we are using the same frequency at a particular distance of 6 R. The cluster size is 12. So the cluster size is 19, it is 7.55 R. So the reuse distance is the distance between centers of cells that are reusing the frequency groups. So for hexagonal cells, the cell shape is here hexagonal. For hexagonal cells, the reuse distance is given with the formula of D is equal to root 3K R, where K is the cluster size, R where we can call the cluster as frequency reuse pattern, and capital R is the cell radius. So you can see here some more, the clusters are more, 4 clusters are there here. This is one cluster, this is one cluster, this is one cluster, this is one cluster. The cluster size is here 7 because we are reusing the 7 frequencies number of times. So the repeated regular pattern of cells is called a cluster. Since each cell is designed to use radio frequencies only within its boundaries, the same frequencies can be reused in other cells far away without interference in another cluster. Such cells are called co-channel cells. Here you can see in this figure the blue shaded cells, this F1. All these are the same frequencies. They are maintained at a distance of capital D. That is root 3K R. So all these cells are called as co-channel cells. The cells which are using the same frequency by maintaining a certain distance of capital D are called as co-channel cells. So the frequencies in the group is in the cluster are F1 to F7. So cells form a cluster. Example 7-cell cluster of hexagonal cells we are showing here in this figure. A reuse cluster, its structure and its frequency groups are repeated to cover a broader service area. Here you can see the same cluster is repeated and reused to cover this broad service area. So in this way, the same frequency we are using or the same channel we are using number of times. So here the available channels are fixed, but the way we are using it is increasing the spectrum efficiency and it is able to provide to more number of subscribers. Okay, cellular networks. So segmentation of area into cells. We are segmenting into the different cells. This is the ideal shape of the cell. So we are using several carrier frequencies, not the same frequency, not joining cells. We are maintaining certain distance of capital D, and the cell size vary from. Cell size means here the coverage area, the geographic location. It depends upon some 100 meters to 35 kilometers. The cell size we are calling the cell size means it may be 100 meters, it may be 20, it may be 35 kilometers. So depending upon user density, geography and transceiver power, the cell size will vary. The hexagonal shape of cells is idealized. That is, already we have seen, we have taken the cell shape as the hexagon shape, which is closer to the was circular shape, which the pattern of the antenna array, isotropic antenna pattern will be in the shape of the circular. So as it is the hexagonal shape is nearer to it, and we are having some other advantages. So because of that, we have taken the cell shape as the hexagonal shape. If a mobile user changes cells, then it is called as the handover. That problem is also looked after very nicely in the case of this cellular concepts. So we can see here the different clusters of different sizes designed for frequency. You can see here 3 cells, repetition of 3 cells, it is k is equal to 3, repetition of 4 cells, repetition of 7 cells, 9 cells, 12 cells, 13 cells, 16 cells. This pattern will be repeated number of times. In the same frequency we can use number of times by maintaining the distance capital D is equal to root 3k r. So this is called as the concept of frequency reuse and cluster. So, okay. So in the next video, we will see the concept of what is the improving capacity. How can we improve the capacity? Thank you.